sharing of your laptops or whatever. All right, I'm going to try to go through 4, 5, 6, maybe even 7 tonight. If I go through 7, I'll definitely go through 8. 4 will be easy, 5 will be easy, 6 will be easy, 7 is going to be the pain. But if you remember, I said you didn't have to put these down here, but I'm going to go through the process of putting together these servers. So you can do a little bit of testing once you've gotten everything kind of set up. All right, so to put a server on a network, I think I need to go to End Devices and Generic Servers. So I'm going to change the display on this guy. So .4 is my AD ACS server. Alright, I'm going to go into the interface and make sure I put the right IP in there, 192.168.50.4 I think it is. Yep, 50.4. Again, this is the local IP that I'm working off of, not the NAT IP. We'll get to that here in a question or two. The local IP. Subnet mask. Alright. And then over here on the services tab, you see all these different services I have. I don't really have a AD service, all right, but I do have AAA. And if I go back to this, I don't have a BlackBerry service, but I can put up a web. I think I can put up a mail server or a file server. But with the AD ACS server, what I can do is set up AAA. Go ahead and just make it radius. The clients would basically be R1, R2, and R3. And you want to kind of make them the closest IP to this server. So if we do R1, the closest IP is going to be 201.68.109.129. 201.68.109.129. Right? And I don't put a secret, I don't tell you what a secret is. Anytime I ever it asks you for a password, always make the password Cisco unless otherwise said. You click Add. Same thing with R2. R2, which is the closest one to me, I want to go with its local IP, 192.168.50.1. Cisco. And R3, which is 201.68.109.131. Okay. And just make one of your users that would be on the router. So if you go back, I'll have you make users in here anywhere. I don't think I actually do. No user, no user, no user. Oh wait, I do have you set up AAA. Woo. We're getting ahead of ourselves here. That's cool. Use Cisco 123 as a radius key. Well, I lied, didn't I? Whoops. You have to go back and edit it. Oh, we can't edit it?
Hit the Q on the top. And then just save it.
Oh, there it is. Cisco 123.
There you go.
Oh, they want it capitalized. Always important.
Wasn't one of them R1?
Hmm?
Wasn't one of those R1? You have 2 R2s.
Oh, wow. All right. Oops. R1. Well, that's crazy. All right, let's do this all over again. R1. R2. All right, they're all in there. Great. Okay. So that's all I really need to do for the AD server. Going back here. I have a file server at .10. Okay. Now, any file services here? No, not really. We don't need to do that. I guess we can make an FTP server. Or do we not have? We already have an FTP server somewhere. Nope, FTP would be on 10. So let's go ahead and set up a FTP server. Yeah. So username Cisco, password Cisco. There, read, write, download, upload, change. Look at here, look at all these different already there. Throw in packet tracer. Perfect. Alright, so that's set. That one's set up. Next one. Our mail server, 50.25. Service will be email. Okay, SMTP service on, POP3 service, it doesn't really matter. Domain, Cisco.com, user, admin. Okay. Deal. And we have a web server. .43. HTTP. All right. a BlackBerry server right now. So I'm going to connect all these up to the switch. Switch is flat, don't worry about it. Plug it into whatever port, it doesn't matter on the switch. Okay. If you're worried about them not having connectivity, it's fine. Go into the switch itself. They're starting to green up. There they go. So they're getting connectivity. You can always test it from any of the routers by just pinging the IP. Got 4. There we go. We have connectivity now. Cool. All right. So I wanted to do that. Configure a static default route to the ISP router. Ensure the route is seen by all. There's 2 things, seen by all downstream devices in the network. OSPF will need to originate a default route on R1. So this is all done from R1. Okay? And you have to create a default route to the ISP router. You do that with the IP route command. Did this already in lab 1, so you know a default route is all zeros. And then the IP address of the ISP router, 201.68.109.97, if I'm not mistaken. Yeah, 97. 201.68.109.97. 201.68.109.97. Okay? Now, here's the problem. If I go into R2, this is why I say you have to do this work in OSPF. You know when I did the show IP route, you don't see an all zeros route there, do you? But in R1, if I do a show IP route, you do see it. Okay? So I've got to get this into this without typing the static route in R2 and R3. I could, not a problem, but kind of defeats the purpose of dynamic routing. So what you have to do is you have to go into OSPF and tell it to look for a default route, and if you see it, redistribute that default route into OSPF so it's picked up by other routers. You do that in OSPF. How do we get into OSPF? What's the command? You paid attention? Tuesday? How do I get into a routing protocol? What's the router? There you go. OSPF. Whatever I named it.
100.
100, yes. That is what? The process ID. All right? Now I kind of try to make this easy in the question, not to trick you or anything. OSPF will need to originate a default route. I do a question mark. Default dash information. That looks promising. Originate. That's it. I go back to R2. Do my show IP route again. There's my static route that I'm learning from R1. That completes number 4. Number 5, on R1, configure and apply an access control list that will prevent RFC 1918 networks from being sent out to the internet. Okay, so, am I going to make a standard or extended ACL? What would be better? What's the difference? What does a standard ACL look for? What does it only care about? Test question, you guys need to know this. It only looks at what in the IP header? No, I said the IP header, not the TCP header.
Destination.
Close. If it's not destination, it looks at source IP and our IP network. Source IP or source IP network. All right? So, configure and apply an access control list that will prevent all RFC networks from being sent out to the internet. So we're looking at source IP information. Source IP information. So I know I got to do this on R1 because I can tell you to do it on R1. So I've got to write a standard access list. Let me get out of router configuration mode here. All right, and I can do an access list and number it from 1 to what? What's the numbers for a standard access list? 1 to 99. All right. Well, there's a higher one up there too. 1,000 through 1399, I believe. All right. 1,000 through 1199. Or I could do an IP access list that is a standard access list. Either way, perfectly fine. You'll get all points for it. Okay? And I'm going to name a standard access list. Typically, I name an access list relating to what it's doing. So in this case, I'm going to name it RFC 1918. So, do I want to, if it says I'm wanting to prevent, what do you think I want to do? Permit or deny? Deny. Very good. Deny. Address. What's the first address in the RFC 1918 scope? Or any one of them, not the first one, but any of them. You see how much you really guys have to dig into this information and commit it to memory? You guys are like right now thinking, oh crap, I really should have paid more attention in 307. Because this is stuff that I know you were tested on in 307. 10.0.0.0. Wildcard bits. What's the wildcard bit for the 10 Class A network? 0.255.255.255. Okay? What's the second network in RFC 1918? I got denier, right? You guys are killing me. You guys are killing me. Is it like the end of the week blues? Or like, God, Professor Brown, just give us the midterm already? No, don't do that. Okay, I won't. I promise. The 172, right? So 172.16.0.0. And wildcard mask on this one, if I'm not mistaken, is 0.15.255. Is it 31? One, 2, 4, 8. And it is 130. It is 31. 31.255. And last one's really easy. 192.168.0.0. It's Class B, right? Wildcard bits would be 0.0.255.255. Am I done? What do I gotta do?
Permit.
What?
Permit any.
Permit any. If I don't, what happens?
Ridiculous.
I break the internet. You're absolutely right. All right, now I gotta apply this guy. So if I gotta apply this on R1, what interface should I apply it on? Should I apply it on the interface facing the ISP? Or should I apply it on the interface that is facing the OSPF domain?
The domain.
The domain, you're absolutely right. Now, the hard question, why?
So you don't have to process it. It just
Bingo! Very good. Give the man a Cupid doll. Good job. So I want to go into, this is going to be Fast Ethernet 01. And the command to apply an access list is what? IP access group. The number or the name. What did I name this guy? RFC 1918. And is this going to be inspect traffic coming into the interface or going out of the interface? Going out.
coming in.
Coming in because it's facing the domain. All right.
If you were to put it on the other side, it would be going in.
It would protect those. Yeah, it would be coming into the domain. Now you can do that, but you lose a couple of points because it's not in the direction I told you to put it in. All right. If you got everything else right, you got the access group right, the access list right, I might take off a point or two if you put it on the wrong interface or put it in the wrong direction.
If it's in the wrong interface, it wouldn't work, would it?
Again, it would not work for that question. It would work. It would prevent any RFC 1918 addresses coming into your domain, not leaving your domain. I specifically said prevent it from going out. Okay? That's good. Okay. This is why we read through the lab first. Re-IP the core transport network from 201.68.109.128/25 to 201.68.109.128/29. What am I asking you to change and where? What am I asking you to change and where? I'm looking for something a little bit more specific. Okay? This is your transport network. See that? Core transport network. It has that IP, subnet, 201.68.109.128/25. I'm asking you to make it 201.68.109.128/29. What interfaces am I dealing with? I'm dealing with interfaces on R1, R2, and R3 that have the public IP and the OSPF network, right? They're attached to this switch number 0 or switch 1. If I go onto those interfaces, what do I need to change? Do I need to change the IP address? Who says I need to change the IP address? All right, so if I don't change the IP address, what's the only thing left to change?
Just the subnet.
The what? The subnet mask. So I go from a CIDR/25, which is 255.255.255.128 to a /29. That's 255.255.255. What?
248?
Close. That's a /28.
50.
248. 248. Okay? Let me give you guys a little bit of a hint. Okay? It is very important that you have a good grasp of subnetting, CIDR notation, these major RFCs, port numbers, what service uses what transport protocol, TCP or UDP, how it operates, is it unidirectional, bidirectional, TCP handshaking, right? SYN, SYN-ACK, SYNFIN, right? It's a really good idea that if you're going to go into this industry and into network engineering, network security engineering, you got to know this, okay? Now, right out of the gate, going into your first job, do you need to know it? No. But guess what? The more you know, than the other people interviewing for the job, the more likely you are to get that job. Okay? Just saying. So, let me go to R3 first. If I do a show run, now look at my interface. There's my interface, 201.168.109.131. If I go into that interface, all I have to do is change the IP address. Excuse me, the subnet mask. I don't have to take it out first and put it back in. I can basically just overwrite it. Okay? When I do that, it's going to kick me off the network. All right? So, a little bit of now we're working in Packet Tracer where we have console access to everything else. Think about this for a second. Let's say this is Atlanta, this is Chicago, this is Los Angeles. You goof something up somewhere, right? You're in Atlanta, well, I can fix that, I can just put it back, right? If I goof something up somewhere, and I gotta go get on a plane to Chicago, guess who's not really gonna be happy with you? Well, one, your boss. Two, your buddies who you were probably gonna go out to have dinner with that night, right? Whatever plans you had. You need to be very, very, very careful before doing stuff like this. All right? Plan it out. Because if I did that, now I've lost all connectivity to these two routers. So what I should have done in the first place is done one router and then the other and then the other. All right? Because if I would have done that, if I would have been SSH from, say, the workstation network, it wouldn't have been a good day. All right? But hey, in the test environment, all is good. We can look at everything and fix it. So I'm on 0, 0 here. All right. And R2 and R3 now want to talk to each other. That's good. Go back onto R1. My interface. So I'm on 0, 1 here. And once I do that, the whole domain comes back up, we're back to normal. So that was question number 6. Okay? Question number 7. You want to set up static NAT on R1 with the following entries. You want to make sure that from the outside world, if I have packets coming in from the internet, to get to these servers on my server network, my DMZ, they've got to hit these public IPs, not the private IPs. Because what I do at R1, what I prevent with an access list.
Internet?
No, I prevented RFC 1918 addresses from getting to the internet, which they can't get right on the internet anyway. So I've got to put NAT on those devices. I got to do a static NAT for each individual device. I'm going to do all of that at R1. All of that at R1. All right? So, NAT on a router is a little bit different than doing NAT on a firewall. Okay? All right? The easiest way that I can tell you to remember this is to probably go to Cisco's website or go to Google and look up iOS natting. are static NAT, static source NAT is actually what it's called, for iOS. Cisco, iOS, static NAT. Alright. Sample configuration using the IP NAT outside source static command. This is a good little paper to read because it kind of tells you how everything works. Alright? But they're using private addressing versus public addressing. So you have to kind of know which direction everything is going in. Actually, they do use public addressing. They use the 171 network. So here's my private network. Here's my public network. So I want to look at router 2514K or X 2514X. That's where the natting is going to happen. All right. IP NAT outside source static 172.16.89.32, which is this guy.